Alright folks, this video is going to discuss some of the fingerprint features that fingerprint analysts use to first classify fingerprints and then to go ahead and compare fingerprints ultimately to identify them. This first video is going to talk about the first few features, and then there will be subsequent videos which will talk about the other ones. Some of the fingerprint features that will be discussed in these videos include fingerprint ridges, pattern area, type lines, deltas, fingerprint cores, how to do a fingerprint ridge count. We're going to talk about what are known as Galton points, ridge characteristics or minutia. And then we're also going to talk about pore patterns and ridge shapes. All right, so let's talk about the fundamentals of fingerprints. It's important to understand that a fingerprint is truly unique. Fingerprints are what we refer to as individual characteristics. And individual characteristics are any features or characteristics that only one person or object has, making them truly unique. An example of another type of individual characteristic might be a scar that you have on your body, or maybe even a tattoo or a birthmark. In some cases, even your DNA is individual. It's important to know that there are no two fingers in the entire world that possess the same or identical ridge characteristics. So every fingerprint is unique. You figure there are about 7 billion people in the world. You figure if each of them has 10 fingers, there are roughly 70 billion fingerprints in the world, and we know that no two of them are exactly the same. Another fundamental of fingerprints is that fingerprints remain unchanged during an individual's lifetime. We knew that fingerprints develop before we are born. So we actually are born with fingerprints. Those fingerprints stay with us our entire lives, and we have those same fingerprints even after we die until our skin decomposes away. Another third fundamental of fingerprints is that fingerprints have general ridge patterns that permit them to be systematically classified. So we know that there are these general patterns that we can place fingerprints in. Another fundamental not listed here is that fingerprints contain unique points or characteristics that can be used to identify specific fingerprints. In terms of fingerprint development, it's important to understand that fingerprints, again, develop before we're actually born. So before we're born, we actually develop fingerprints as we are developing within our mother's womb. In fact, fingerprints form during the second trimester of fetal development, so somewhere between month 4 and month 6 of gestation. And so we're born with fingerprints, and we maintain those same fingerprints throughout our entire lives. Even after we die, we have those same fingerprints. There have been fingerprints taken from mummies that are over 2,000 years old where the skin has been preserved, and we can actually see the fingerprints on that skin. And so the fingerprints that we have when we're born remain with us even when we die. And our fingerprints don't change, and that's because of how fingerprints are formed. It's important to know a little bit about how fingerprints are formed. We know that skin, human skin, is actually composed of 3 layers. The outer layer, the part we can see, is called the epidermis, and that is the area where the friction ridges that make up our fingerprints actually show up. But the shape of those ridges actually forms in the middle layer, the papillae layer, and that is a boundary of cells that sit between the epidermis, the outer layer, and the dermis, which is the very most inner layer. And the shape of this boundary of cells determines the form and pattern of the ridges in the epidermis. So the interesting thing is if you damage the outer layer of your skin, which happens all the time, if you get a cut or a minor burn, the outer layer of your skin can be damaged, sometimes even with a burn. Say, for example, if I put my hand on a stove and I burn my skin, sometimes that skin can then blister up and even peel off, but the skin grows back. And because the shape of the friction ridges, which make up my fingerprint pattern, is not actually formed, even though it shows up in the outer layer, it's not actually formed in the outer layer, it's formed in that middle layer. My fingerprints, when they grow back, will grow back exactly the same way they were before. The only way the fingerprints change is if we get a deep tissue wound, some sort of really deep tissue burn, like a 3rd-degree burn, or a really, really deep cut that causes permanent scarring. It's only in those cases that actually the fingerprints change. If there's no major damage to the skin, then the fingerprints stay the same throughout our entire lives. So where do our fingerprints come from, or what are they? fingerprints, as we mentioned before, develop during the second trimester, and fingerprints are made up of what's called friction ridge skin. So we have these what are called friction ridges, and if you look closely at your fingertips, and even actually at the palms of your hand, you can see this friction ridge skin. It's these raised ridges, these hills and valleys that form these patterns on our palms, on our fingers, and actually friction ridge skin is even found if you were to look at the bottom of your feet. You'd find friction ridge skin on the bottom of your feet and on the bottom of your toes. And the reason we have this friction ridge skin is it provides friction, it provides grip. Friction ridge skin is kind of like having a tread on the bottom of your shoe or tread on a tire. And the reason we have tread on a tire is when you're driving, it allows the tire to grip the road so that your car doesn't slide off. Well, this friction ridge skin, when you're walking around in your bare feet, it provides a little bit of grip so that your feet don't slip and slide as you're walking around. Or in your hands, it provides a grip, so if you're gripping, let's say, a handle to a tool like a hammer, it doesn't just slide out of your hand. So we have this friction ridge skin, and these friction ridges, interestingly enough, they form patterns, which are what make up our fingerprints. Now, the skin, sometimes we get dirt or grease or oil and sweat on these surfaces, like our hands and our fingers. And when we touch things, this oil and dirt, sweat, residue that's on our fingers transfers to things that we touch. So, for example, if I touch a tabletop, the residues from my hand are transferred from my fingers to the tabletop. And the residues are going to be in the shape of the friction ridges on my skin. And so we leave behind these patterns, these fingerprints. And so that's where our fingerprints come from. So they come from these friction ridges. Now, we need to know something about what's called pattern area, because when we classify fingerprints, we're really only looking at certain areas, a certain area of the fingerprint to do the classification. If you were to look at your palm of your hand, you would see that your entire palm is covered in friction ridges. So the palm of the hand is covered in friction ridges. If you were to look up and down the finger, there's friction ridges on the undersides of the fingers, in the first knuckle, the second knuckle, of course, the pad of the finger, and even here on the tip of the finger. But the pattern area, the part of the fingerprint that we're most interested in terms of classifying the print, and normally in terms of comparing it, is this area here on what's called the pad of the finger. This area here, this is what's called the pattern area. And the pattern area includes things like the fingerprint core, the delta or deltas, and then the ridges that make up the pattern that are part of the classification of the print. So that's what we call the print or pattern area, rather. So for example, this fingerprint, the pattern area is the core, which is the middle portion of the fingerprint. So we can see a core here, and we see on this fingerprint the core here, and then what's called the delta, which is this kind of triangular shaped formation here, and then we can see that triangular formation here, this delta here, which we'll talk more about later. And then the ridges that make up the classification portion of the pattern, which is kind of in the middle portion. So these outer ridges, which are important for comparison, are not necessarily part of what we call the pattern area, whereas the core and these deltas are. That's what we call the pattern area. There are three primary fingerprint patterns, so we use the pattern area to identify or classify the fingerprint into one of three main classifications, which are arches, loops, and whorls. And then there are sub-classifications. For example, there are ulnar loops and there are radial loops, and we'll talk more about those later on. But for now, we use the pattern area to determine whether or not a fingerprint is an arch, a loop, or a whorl. To give you an idea of the distribution of patterns, only about 5% of fingerprints are classified as arches, so arches are the most rare. The most common are the loops. Loops make up 60 to 65% of all fingerprints, and then whorls make up 30 to 35% of fingerprints. If you were to look closely at your own fingerprints, you might see that you probably have a mixture of loops and whorls and arches. You might, very rarely do we have a person that only has just arches or only has just loops. Usually they have maybe a couple loops, couple whorls, maybe an arch, but you see the distribution there. Certainly the most common fingerprint pattern is the loops. Now how do we figure out what type of fingerprint it is, if it's an arch, a loop, or a whorl? Well, one of the main things we look at is what's called ridge flow. Ridge flow is basically the kind of what happens to the ridge as it moves in from one side and out from the other side. So we can see this particular fingerprint is an arch. And again, arches are the least common, of only about 5% of fingerprints are arches. But with an arch, we see that the ridges, they flow in from one side. They have a tendency to rise up in the middle, or kind of form an arch in the middle, and then flow out the opposite side. So they flow in, they rise up, and then they flow out. I do want you to notice the ridges, though. Typically ridges break or they separate, bifurcate. And so it's not that one single ridge, but the tendency is most of the ridges flow in from one side, rise up, and flow out the other side. So we see this kind of arching ridge flow. On the other hand, with this fingerprint, we see that, yeah, there are some ridges that flow in and do arch across the top and flow out, but then there are some ridges that actually circle or form a circuit pattern in the middle. This is going to be an example of what we constitute as a whorl. So now we see a ridge flow that has this somewhat circular or circuit pattern in the middle of the fingerprint. And so what we're looking at here is a whorl. Whereas some fingerprints, like this one, have ridges that do what's called a recurving ridge flow, or they have recurving ridges, which we see if there's these fingerprints that flow in here from the right-hand side, and then notice they kind of do this U-turn. And then they flow out the same side. So we have recurving or kind of U-turn ridges. They flow in from one side, and then they do a U-turn, and then they flow back out the same side. And this is an example of what we'd call a loop. And loops can be ones that flow in and out from the right side, or we can even have loops that flow in and out from the left side. And so again, this is what we call ridge flow. And so by looking closely at this ridge flow and some other characteristics, we're going to be able to determine whether or not the fingerprint is an arch, a loop, or a whorl. So again, we look at the pattern area, we look at ridge flow to figure that out. And then there's some other things we're going to look at a little closer too. We're going to look at things like recurve and core and delta, but those things we're going to talk about in the next video.